Hi everyone. Alright, so in this video, I'm going to go over convolution for continuous linear time invariant systems. Okay, and so to start off, let's talk about the convolution integral. Convolution integral. So for continuous signals, you apply an integral because integrals are for continuous signals. So y of t equals the integral from negative infinity to infinity of x tau h of t minus tau d tau. And so this is equal to x of t convoluted. This is a symbol for convolution. This right here, what I just highlighted in pink. Convoluted with h of t. So let me draw this out. Y of t. Nope, just kidding. I meant to write x of t. X of t is your input signal. And what are you inputting it into? A transformation, and we're going to call it capital H. Well, it's an ugly box. And your output is y of t, or your system response. And this is your system, we'll call it H. And so what's this little h of t? Well, this little h of t is called the impulse response. And what that means is if your input signal is an impulse, your h of t is your output after it's been inputted into the system. So it's kind of like delta t is your input signal, and you put it into the system H, and so your response would be h of t, or in other words, the impulse response, right? But for now, if you're given a continuous signal, you'll use this equation to find highly better to find the convolution. Okay, so let's do an example. Oh, wait. Okay. Example. Where is the... Okay. Example. I tell you your input signal is e to the minus 2t times u of t. And your impulse response is u of t, or the unit step function. And I want you to find y of t, which is the convolution of x of t and h of t. And so I gave you the equation before. I'm going to rewrite it so I remember it. Minus infinity to infinity of x tau of ht minus tau. Oh, this is supposed to be a tau. Tau d tau. Okay. So I give you x of t. So let's write it out. Infinity to infinity. Infinity to infinity of e to the minus 2 tau u of tau. U of tau? Yeah, u of tau. Because you're replacing the variable t with tau. Right? Okay. And now for h of t, you're replacing the inside of h with t minus tau. That's right. Oh, there we go. the inside of h is t minus tau now instead of just t, as I've given you. So then that becomes u of t minus tau d tau. Okay, so let me scroll up. Actually, let me write that closer. Y of t. Let me scroll up so I have room on the screen. Okay, so this is the integral you're going to be working with. And it looks really bad. But you can simplify this part right here. Actually, you can simplify this part. Let me show you. So this is two signals being multiplied together, right? Draw out each signal. So for u of t, that's your, okay, that is your unit step function. Oh, u of tau. So that is, oh, wait. That's just a unit step function with the variable tau. Okay. The second part, I'm going to rewrite the equation. I'm going to rewrite this u of t minus tau as u of minus t plus tau. And so, based on the video, based on signal transformations with the negatives and stuff, this signal now looks like this. And it's centered at t. Yeah, this is t. Let me change that color, actually. This is t, and your variables are tau and u of minus t plus tau. Because the negatives flip it about the axes. And you're shifted by t. Yeah. So, as you can see here, if you multiply these two functions, anything on this side, let me change my color. If you multiply these two functions, anything past 0 is going to be multiplied by 0 because of this function, this segment right here. And anything past t is going to be multiplied by 0 because of this segment of the function. So your bounds end up changing. So you can simplify your bounds by, I am running out of space. Okay, y of t equals 0 to t of e to the minus 2 tau d tau. And so your integral, I'll scroll up from a room. Your integral simplifies to this, which is a lot more easier to solve. So this ends up being 1/2 e to the minus, this becomes 1 minus e to the minus 2t u of t. Yep. And so that's how you use this equation, the equation we started off with, this one, to find the convolution for continuous linear time invariant signals. Sorry. Yeah, so that's it. Thanks for watching. See y'all later.